Thank you, everyone, coming to this talk. My name is Kelvin, and I started working on Spot since version 07. When I was at Uyala in my last job, I co-created the open source project, Spot Job Server. It is a job server for giving out a lot of RESTful API to help people to submit their Spot jobs, manage their Spot jobs, and monitor their Spot jobs easily. And then I joined Goober in the summer of last year. Goober is founded in 2010. The original idea, which is also the still most popular feature today, is with just one tap on your phone, anyone can get a ride from at anywhere to getting them to anywhere. We are a technology company. We build software platform for driver partners and our riders. Just to give some idea for the scale of our data and also the scale of our software system, we run the business at more than 300 cities in 58 countries. We have hundreds of thousands of driver partners and millions of riders. And every day, we have more than 1 million trips around the world. At Uber, I'm in the data platform team. The team was formed last year summer, and I was the second engineer. It is part of the larger data engineering team. The team members have very diverse background, and we have creators, committers, contributors to many open source projects. And the current focus of the team is to build something we call a data lake. The idea is at Uber, we have many data sources, data coming in different places in different data formats. It is very inconvenient and sometimes impossible for the people to connect the data together and use the data easily and efficiently. So there are many parts of the data lake system, and mainly there are two major components in the system. For the first one, we are working on the data ingestion pipeline. The idea is to build a data framework to get the data from different places and put them into one place. The final goal is we have all the data in one place. And the second part of the system is on the data consuming side. People build application on top of the data lake to use the data easily and efficiently. So in this talk, I'm not going to cover the data ingestion pipeline, but my colleague, Winner and Wino, they are going to speak about it here in the Spot Summit this afternoon, also at this room. And their talk title is Scoop on Spark for Data Injection. So for those who are interested in the data ingestion topic, what we are doing with it, please join them in the afternoon here in this room. And in this talk, I'm going to discuss the data consuming side. And before I do that, let me first talk about the challenge that we want to solve at Uber. So this challenge is going to drive our decision of how to build our system. And we have many design factors that we need to consider. But for the presentation, let me just list the three most important design factors here, or challenge here. First, the data lake platform we are going to build will be shared by many multiple teams at Uber. And the teams, they have different business or technical background. So some of the team, they have stronger engineering and distributed system background. And some of the team, they come with stronger data science and math modeling background. And then also, some of the team, their day jobs may not be focusing on the technical part of the Uber business. Maybe their day-to-day job is focusing more on the business side of the Uber company. And then another challenge is we only have one lake, but people is going to build many different applications, different use cases on the same platform. So when we are designing the data lake system, we need to keep it in mind that this is going to be like, need to be like flexible enough for multiple teams, at the same time powerful enough to support multiple use cases. And also, one last thing is like the different application, they have different SLA. Some of the application, they are okay to be, have longer latency, but they need to deal with a lot of data. And then some of the use case, they require shorter latency. They need to get the data like as soon as possible. And this is all the challenge and design consideration that when we are designing our system, we need to consider. So the data platform team, we build a lot of software tools by ourselves to support the framework infrastructure. At the same time, we also use a lot of open source software. And today here, I'm going to talk about 3 of them. So first of them is Spark. So why are we using Spark at Uber, right? So, so the number one feedback after I worked with multiple teams at Uber, the number one and most popular feedback I got from the team is like Spark is very easy to use. I have cases, I work with like data science and engineer. They may not have Scala, they didn't use Scala before, they didn't use Hadoop or any Spark before, but then with 1 week, they can pick up both Scala and Spark, and at the end of the week, they can have something running in prototype already, and then eventually they can, based on this prototype, add things and work on things incrementally, and eventually they will have things running in production. So the first reason that why we are using Spark at Uber is like it's easy to use. Also, remember that like our data lake, we need to support like many different use cases, and Spark has a very strong ecosystem. Like for example, we have batch jobs like ETL, and Spark originally was designed for this purpose. And then we have analytic use cases that we can leverage Spatial, and then we have machine learning team, they can leverage the MLlib. A strong ecosystem around Spark is another reason that why we want to use Spark at Uber. And then Yang, we also use Yang. We run all our Spark jobs on Yang. And so before I talk about how we are using Yang, like, let me just get an idea. How many people here have used Yang before or are using Yang in the production system now? Very cool. So it's about like 25%. Like at Uber, we use Yang. Main reason is like because for the resource management. So again, like we have multiple teams in the same system. We want to have some kind of isolation between their jobs and between the team. And also, we want to have a layer to do the resource allocation jobs for us. And Yang can do these things easily for us. And Yang can also like optimize our cluster throughput for us. We don't need to do it by ourselves. And another good thing about Yang is like it has a very nice integration, Hadoop security integration with Spark. So just to show some idea how Yang work and how Yang work with Spark. Let's say we have a bunch of machines and it is a Hadoop Yang cluster. And then we have Spark jobs coming from different teams at Uber. They are trying to do different things. And then in Yang, there's a resource scheduler concept, and it is pluggable. And there are many choices for the scheduling logic. And the scheduler, it does a lot of different things. But mainly, there are 2 things the scheduler will do when a Spark job comes into the Yang cluster. So the first thing is like Yang will decide for this job which resource queue this job belongs to and should run that job in that resource queue. This is the first thing the scheduler will do. And then the scheduler will also allocate the container, and in our case, which is the JVM container for the jobs. That is the first thing, the placement and the allocation. And then the next thing, the Yang scheduler will try to have the optimization logic for the Spark job to try to optimize the throughput of the cluster. So, so this is a overview of a yarn-like architecture. So when a smart job is submitted from the client, it first goes to the resource manager. And then the resource manager will create a application master in one of the machines. And the application master will launch multiple JVM containers in the different machines of the cluster. And for the Spark scenario, the Spark contacts the driver. If you are running in the cluster mode, your Spark contacts and the Spark driver will be inside the application master. And your Spark executor will be running in the JVM container launched by the application master. So yarn launch the application master, put the Spark context inside the application master, and then it handle all the forwarding logic back to the Spark, and Spark just forwarding its original Spark workflow logic to launch the job, launch the task to the cluster. Resource queues. So the resource isolation and the jobs isolation is done and handled by the resource queue concept in Yarn. And when I say resource, and when Yarn say resource, it means two things. It means the CPU and the memory. And this is one of the examples that how we are creating the resource queue at Uber. So the resource queue starts from the root node, and then each team is assigned a resource queue in the hierarchy. Let's say team 1 get their team 1 resource queue, and then team 2 get their team 2 resource queue. And then we have one resource queue called critical, meaning that any jobs, all jobs in that queue is all business critical. And we have to make sure that all the jobs in that queue has to succeed, has to get all the necessary resource they want to have. And then there's another one, another queue called default. If the user doesn't specify the queue names, or they don't need to have the resource guarantee, then their job will run in the default queue. And then based on the priority of the queue and the jobs, how important, how critical is the job, we assign different priority, different weight to the queues. And for example, since the critical jobs run in the critical queues and we want them succeed, we want to guarantee that it will get all the resource. The critical queue get the largest weight in this case. High availability. So we also take advantage of the HA feature of Yarn. When the Spark job is running in the custom mode, the Spark context is inside the application master. And if the application master die or crash in the middle of the job, the Yarn will automatically recreate the application master and the Spark job transparently for us. So we don't need to do anything. It is automatic, and it is handled by the Yarn. If in other cases, if the executor failure, it will be handled by the Spark logic itself. The data platform team at Uber, we have done a lot of HA tests. We have tried to queue the Yarn resource manager. We try to queue the Yarn node manager. We also try to queue the job application master, random Spark executors, history server, and the good news is all the tests are passed, meaning that the existing Spark job, they can still finish after the recovery, and new job can still submit to the cluster. And this is a major milestone for our Uber Ops team. After they finish this test, they feel comfortable that okay, Spark is ready for production. But there's one catch. If you are using a version before 1.3, there's one bug that you need to set a flag, which is the spark.event-log.override. Because when the application master die and they try to run the jobs again, they try to reuse the last application ID. And because the application ID, the directory exist in the HDFS file system already, when they try to put the data in the same directory, the job will fail if you don't set this flag. So the solution is like either use the version 1.3 or 1.4, or you set this flag. Security. Security is very important in multi-tenancy platform. So we have one data lake, and multiple teams are running on the same data lake. Some teams, they want to protect their data. They may have data that they don't want to share with other teams. They don't want other teams can see it or use it. And then to enforce this kind of security, Yarn is the only choice. Of cluster manager for Spark. Spark support standalone cluster manager, Meso, and Yarn is the only one that you can work with Spark and the Hadoop Kerberos security feature. The Kerberos will handle the authentication for you, and the authorization of the data is still handled by the HDFS itself. And again, there's some tricks or tips in this security on Spark with Hadoop. One of them is the thing called like delegation token. So it's the security token. And this token will expire. And by default, it expires in 7 days. So let's say if you are running a long-living Spark job, like for example, if you have a Spark streaming application that it runs forever, right? Then your token will expire. So what you have to do is like you need to renew your token. And another thing like we also ran into is like when we are using the Hive context in the Spark SQL with the security feature on, we also run into some problem that some exception is thrown and there's a bug tracking in the Jira. So in a high level, basically Spark and the security in this area, there's still some tricks and tips. And if you are going to use Spark in a secure environment, prepare that you need to do some research and a lot of testing. One question like many people ask me is, when they are using Yarn, how about the Spark UI? Can they still use the Spark UI with the Yarn UI? And the answer is yes. The Spark team and the Yarn team, they have done a very good job to integrate the two UI very nicely. From the Yarn UI, it is very easy to click into the Spark UI, and then from there you can get a very familiar UI to get do the job monitoring you have been doing in the standalone mode. So I have covered the good stuff about Yarn with Spark, right? And there's some non-easy part, and the data locality is one of them. And the problem is the executor, they are launched by the Yarn manager, the resource manager, before they know that what is the location of the data. Meaning that when the executor is launched, the Yarn resource manager, they don't know where is the data. And there's a good chance that when they are launching the executor, the location of the executor is not the same as the data. Meaning that the data locality will be missed. And it will trigger a lot of remote network I/O in the cluster. And the solution to this problem is we can pass in the location of the data to the second argument when we are creating the Spark context. So there are many constructors for the Spark context, and one of them, it takes the second argument, which is the data location. And then you can easily get the data location from one of the Spark utility method called input format info. That input format info method can help you to get the data location. And it is a workaround in this scenario, even though it is not very easy. And then later in my slide, I will talk about one solution at Goober, how to make it easier. And I have covered all the material of yarn, and now I'm going to talk about parquet, how we are using parquet at Uber. The motivation that we want to use parquets is three things, mainly. The first thing is like we want to use schema, and parquet supports schema. The second reason is like parquet has high performance data access. It can support like different data access pattern. And also, Spark has strong support with parquet. Spatial support parquet since the beginning. And in the case that like if you don't want to use the Spatial, you can always use the parquet input format to get the parquet data. And at Uber, we want to use schema, and the reason is because, again, like we have multiple teams using the same data lake. And we found that like schema is a good contract between multiple teams. Some of the teams, they are the data producer, and some of the teams, they are the data consumer. They may not work together like very frequently. And schema can be a good contract between the teams. And also, when we have our schema, we have types for the data, and this is good for the performance of the analytic workload. And also, schema can act as a documentation of the data. When developer they want to build a new application for the data, they can easily just look into the schema and get some good sense and overview of the data they need to deal with. And also, in our experience, schema can prevent a lot of bugs. And also, in the debugging process, like with a schema, it also helps a lot, like when we are doing troubleshooting. And then when we have schema, then that means like we will have schema evolution, meaning that like maybe we start from schema version 1. And then later, when the business grows, we want to build new application. We find out that we want to add new column or new data into the same data topic. And then like, we will create a second version of the schema. So the schema evolved from the version 1 to the version 2. And Spatial has a very nice feature in Spark version 1.3. For this case, let's say when you have a many data, many files, parquet files, and they have multiple schema, the Spatial will automatically merge the schema for you. So you don't need to do like alter table statement, something like that anymore to change the metadata of your data. You just put in your new data with the new schema into the HDFS system, and then Spatial will do the merging and run the job for you. In our team, we have a lot of we spend a lot of time building our schema tools. We create a lot of service to make creating and getting the schema easily. We also building a validation framework to make the schema evolution easy. When the schema is evolved from like one version to another version, it is usually a manual process. That means it is like error prone. So we have this like validation framework to do the checking, something like a unit testing to make sure the evolution is good. We are also building a lot of programming language library to support the data producer and the data consumer. We also do some benchmarking for the parquet performance. Basically, we use some of our Uber use cases and then run the Spark job with the old file format and the new parquet file format. And then in our measurement, it depends on the use cases, and it also depends on the data access workload. But on average, we found that like the performance improvement is like between 2 to 4 times. And then we also try to identify like what is the reason behind this like performance improvement, right? And one of the reasons is because like we have a very wild table in our data topic. Our data topic has many columns, and hundreds of columns in our cases is pretty normal. And and then because parquet support column pruning, even though like our data topics has many columns, our users, when they are running the Spark job, usually they just need a very small selective subset of the column. And then in that case, the column pruning supported by the parquet helps reduce the I/O a lot. And also for other use cases like machine learning, for that use cases, because they usually used to access every column in the row, but they don't need to access and get all the rows. For example, when they are doing the machine learning per city, right? They want to create one model per city. They just need to get all the rows from that city, right? And then the filter predicate push down feature from Parquet also helps reduce the I/O a lot. And this is all the reason that why the Parquet has a better performance compared to our old file format. So now I want to talk about one of the software that we are building in-house by my team. And basically, we build a lot of software service tools. And one of them, we call it Spark Uber Development Kit. Internally, we call it Spark UTK. So the idea is to help the users get to create their job easily and to help them to run their jobs at Uber easily. So we have a lot of Uber-specific tuning. For example, like many memory tuning at Spark is related to, like, for example, what is your configuration of your container size in Yarn? What is your cluster configuration, right? So the default setting is usually not good for general purpose. And then at Uber, like we create and provide a template class, so that like they can, when the user they want to create a Spark job, the first thing they do is like they extend from this template class, which inherit the most reasonable setting in the Uber environment. And then usually this setting can get them like handle a lot of data easily already. And also we build a lot of methods specific to Uber environment. We use like different data store. We have different input data source, output data source. So we build method and utility methods like run this and also put it into the Spark UDK. The failure, the HA setting, we also put it into the UDK. The common transformation logic, we put it into the UDF. And we also integrate the Spark job with our Uber internal logging and monitoring framework. So I want to like go over some of the use cases at Uber very quickly because of the time concern. Some of the jobs we are running in production at Uber is like we are migrating our data from our old HDFS system to the new system, and then we create a bunch of Spark jobs to infer the schema for the old data, create an Airflow schema for the old data, and use the schema to clean the data, clean the old data. And then also, after the data is clean, we convert the data into the parquet format. And then at the end, we also create Spark job to validate, to do sampling and analytic to confirm that the new data is correct. We also use Spatial for, in some cases, to compute the business metric. We also use Spatial for ETL, data validation at Uber. We also use machine learning. We use decision tree, random forest, boosting tree, k-mean for different machine learning purpose from data science team. And the general feedback is like they love it. The good thing about Spark MLlib is they already have a lot of powerful algorithm in the library. Usually the data scientists, they can easily find the algorithm they want to use in the library already. And then there's some lacking in the library that, for example, like in the random forest, the library only gives you the label, but not the probability. We also do a lot of spatial handling processing at Uber by Spark. In these two screenshot, we are computing some metric on top of our geospatial data. So last thing, I want to do a quick announcement, like the Spark Job Server community. We are having a gathering in the Spark meetup tonight. So if you are interested, please join us there.
So we're a bit over time, but maybe take a couple questions if anyone would like to ask. Start here in the front.
I'm just curious about your role at Uber. So you're building an infrastructure, and then business units can develop analytics, and you're kind of the liaison within the company, or would you be the department that actually builds the analytics? Or can you clarify that a bit? I wasn't clear about
Right,
this.
right. So the main focus of my team, the data platform team, is to build an infrastructure, service, multi-tenancy platform. So we don't focus on specific application use case. Like we have different teams, they are focusing on the application, right? So different teams, they have their own vision, their own responsibility in Uber. They come to our data lake to get the data and build an application on top of the data lake. So our jobs is to make multiple teams possible, working together on the data lake. Yeah.
If you're exiting, if I could ask you to keep it down so we can hear the Q&A.
So relative to schema evolution, do you have a meta store, and do you keep that updated for?
Right.
And how do you go about doing that?
Right. So the answer is yes. We have a meta store. So we build a lot of service and tool around the schema service and the schema evolution. And one of the things is like we have a meta store, so people can create their service, create a schema inside the meta store, and then also to update the schema inside the meta store. And then we are also building other tools to create a Hive context based on this meta store.
You talked about resource allocation at the memory and CPU level, and you said I/O is coming. Is there something you are doing in-house, or are you using something in HDFS?
Cool. So basically, right now, Yarn only support I/O, only supports CPU and memory for resource allocation, and they have Jira tickets for tracking like the I/O feature. So basically, they want to also like put I/O into the Yarn resource management. It's not done yet, and but those tickets are assigned to one of the members of my team. So my colleague, basically he's a contributor to the Yarn open source project, and he's working on many tickets, and one of them is this I/O resource management.
Do you see an issue with I/O being?
There are many issues. And it's a very challenging thing. It's not easy, and my colleague is actually working on it like for quite a long time. Eventually, it will come, and we need a feature too. So, yeah.
Okay, 2 more questions.
So you said you're using Kerberos for authentication. Do you have any Spark streaming jobs where the jobs have to run forever? And if the Kerberos renewable ticket is by default to like 7 days or something, and if it expires, it can't renew after that point.
Right.
So how is that issue solved today?
Right. So let me clarify a little bit. Like in my data lake platform, we haven't used the Kerberos yet. So basically, that slide is just to highlight saying that if you are going to use Spark on Hadoop, and if you need security, then you need to deal with the Kerberos. But currently, we don't have Kerberos security in our data lake platform yet. But it is on our roadmap, and it is a very important thing. And for your Spark streaming.
Is it possible with Spark streaming you can have like the jobs running more than 7 days? Let's say like if I want to run it for a couple of years without having to.
The answer is yes, but it is not default out of the box. You have to build the logic of reviewing the dedication token inside your application yourself. Yeah.
Okay, last question.
You mentioned about I/O support for Yarn, right?
Yeah.
So what is the idea of, how do you intend to do it? Is it going to be based on the number of I/O operations, or is it going to be the volume of data transferred?
Yeah.
Because in many cases, if you're reading sequentially from disks, that's like a lot more cheaper than if you're doing random I/Os.
Right. So basically, those tickets are tracked in the Yarn Jira. So the idea is they will use the C group in the Linux to handle all those like IO rate limiting, resource allocation thing like inside the C group. So it is kind of independent of the Spark. Spark dedicated this work to the Yarn, and Yarn further dedicate them to the C group. Yeah. Cool.
All right, thanks, Kelvin.